Okay, morning everybody. Today we're going to start our first topic of the Year 2 course, and we're going to kick it off with stats, and we are starting with the geometric distribution. So, the geometric distribution means, or is the distribution that gives us the probability of getting a single success on the X trial, okay? So if you are carrying out successive independent trials, each with the same probability of success, you can model the number of trials needed to achieve a single success using the geometric distribution, okay? Now, for example, if you were going to play snakes and ladders and you had to roll a 6 before you could start, it would say what the probability, or how many, it would measure the probability of how many trials you would need in order to get a 6, okay? So you could say, what is the probability that I can start snakes and ladders on the 5th time I roll? Okay, that's what we are looking at, okay? And we're going to kick it off with a little example, and then we're going to do this very much logically first, and then we'll look at what it means in terms of the distribution, okay? So, here we go, bit of snakes and ladders. John is playing a board game where he has to roll a 6 to start. Find the probability that John starts the board game on his 4th roll, okay? So he's doing all these different rolls, he's rolling until he gets a 6, and we want the probability that he gets the 6 on his 4th roll. Okay, so first of all, obviously when you're rolling a fair dice, we're assuming this is fair, then the probability of getting a 6 is a 6, okay? I hope you can read that all okay. Maybe I'll write it out a bit clearer. So the probability of getting a 6 is 1/6. Okay, that means that the probability of not getting a 6, which I suppose we could write as 6 dash, is going to be 5/6. Okay, if we want to get the first 6 on the 4th roll, that means the first time I roll, or John rolls, he needs to not get a 6. So that's 5/6. Think about the tree, not a 6. When you're drawing the probability tree, then he wants another, not a 6. So what am I going to do with those probabilities? I'm going to times them. So I want not a 6, not a 6. The third time, I also want not a 6. And then to get it on the 4th roll, I then want my 6th on the 4th roll. So not 6, and then 6 on the 4th roll. And the probability of getting a 6 is 1/6. Okay? So we can multiply those all together, which gives us 125 over 1,296. Quick maths there by Callaway. And if you put that into a calculator, hopefully that will be 0.0965. Okay, that is correct to 4 decimal places. Right, hopefully that makes sense. So, obviously we can do that really quite easily using our brains, using logic. But obviously we want to have a more succinct way to do it, and we do that via the geometric distribution. So here is the geometric distribution, okay, and this is saying that if we have successive independent trials, each with a constant probability of success. That's important. These are assumptions that we'll be asked to talk about in our exam. Okay, so it's a successive independent trials, each with a constant probability of success. We'll call that success P, like we would in the binomial distribution. Then we can say that the number of trials needed for one success, we will call X, has a geometric distribution as follows. The X is, I messed that up. X is geometrically distributed with a little p, that should be, with a probability p. P being our constant probability of success, X being the number of trials needed for one success. Okay, now I've given you these two formulae, hope you can see them. This is the probability that X is equal to X is P times 1 minus P to the power of X minus 1. Now hopefully that makes sense if we look at this example up here. So the probability of a success in this case was rolling a 6. The probability of that success was 1/6. So we've got one we've got P, that is 1/6 there. But prior to that, we needed to have no successes, and we're having no successes in the number of trials, take away 1. So we wanted our probability of success to be on the 4th trial. So we needed to do 1 minus our success, so our failure, to the power of 4 minus 1, i.e. 3, which is what we did here. Okay, so hopefully that really makes sense where that's come from. And obviously the probability that is less than or equal to x is going to be our whole, take away all of that. Hopefully that is obvious as well. Okay, right, so let's kick us off with a little exemple. Here we go. So the probability that Lucy passes her driving test on any one attempt is 0.6. Find the probability that she passes on her 5th attempt. She needs 5 or fewer attempts to pass. She needs more than 5 attempts to pass, and we've got to state our 2 assumptions. Okay? Right, now as always, you're kicking this off, you're writing the geometric distribution. So I'm saying x is the number of attempts needed. Can we see it? Okay, maybe I can zoom in. Oh, I don't know how. Anyway, we'll roll with this. X is the number of attempts needed. And so x is geometrically distributed with a probability of success of 0.6 because the probability she passes is 0.6. Okay, we would like to know the probability that she passes on her 5th attempt, i.e. the probability that x equals 5. So we can use this formula up here to work out the probability that x equals 5, and you should get 0.01536. Okay, now alternatively, I think in the exam they like you to use these formulae, but obviously you've got your spanky calculators and they will do it for you. So in the stats window, distribution, you have to tab over, and then geometric. Obviously, because we want an equals here, we've got to do GPD. X is the number of trials that we need, so that is 5 here, and our P is 0.6. And happy days, we get 0.01536. Okay, question B said, or question AII, said that she needs 5 or fewer attempts to pass. So 5 or fewer is going to be less than or equal to 5. We can use the probability, the formula that we had earlier, which is this. The probability that x is less than or equal to x is 1 minus p to the power of x. Okay, you can use that again. So we want x obviously is less than 5. Stick it in your formula. That's your answer. Obviously, though, you can also use your calculator. If you go GO, and then obviously we want GCD this time because it's less than or equal to, which we're going to pop in. Our lower, we want to be 0. Okay, you obviously, you obviously can't get 0. You can't get a success on your 0th attempt. Okay, so 0 is as it is. We want our upper to be 5, and our P is still 0.6, and we chuck that into our calculator, and happy days, we get the end the same as that. Okay, right, our third question said we want the probability she needs she needs more than 5 attempts to pass. So more than 5, obviously, is going to be the probability that x is greater than 5. If you did your little list, like I always like you to do, more than 5 means this end, so it is 1 minus the probability it's less than or equal to 5. Obviously, the less than or equal to 5 we've already done. We did that above there, but if not, you just shove it into your little formula. 1 minus that, you should get 0.01024. Again, you can do it on here with your CD. Now, really handily, this has got a lower and upper, so we want our lower, because we don't want it to be 5, we want our lower to be 6, and then your upper needs to be something very large, some sort of million. And then P is 0.6, happy days, we get 0.01024. Okay, that is the geometric distribution. Oh, question B, I forgot about question B. Question B says state 2 assumptions that you have used. Our 2 assumptions that each attempt is independent and has a constant, the same probability. So every time Lucy takes her driving test, the probability that she passes remains the same. Okay, we should now be able to do exercise 3A.